This is lesson 32 about polygons. So as usual, we've got some vocabulary words we need to get down pat. So a plane is a flat surface that extends without end. If I have a piece of paper, that could be a plane if it went on forever and if I could hold it straight. So it's only two-dimensional. It doesn't rise up. It's flat, but a plane goes on forever. It can include polygons. So if I cut shapes out of that piece of paper, those could be polygons. A polygon is a flat shape that has there are three qualifications for polygon. It has no curved sides, so it only has straight lines. It can't have any openings, and they're flat and only two-dimensional. Okay, so fair enough. So let's take a look at the book. I couldn't draw all these because I'm not such a good artist. These are all polygons. So let's look at our three qualifications again. No curved sides, only straight lines. So I don't see any curves, so that's good. They don't have any openings, so they're all closed up. And they're all flat because they're on a piece of paper, right? Okay, so those are all polygons. The line segments that form a polygon are sides. So this side, this side, this side has three sides. And where the two sides meet, the pointy part is a vertex. So this triangle, this three-sided polygon, has three vertices. That's the plural of vertex. So how many vertices does this one have? 1, 2, 3, 4. There's a vertex, 4 vertices. Okay, so no curved sides, no openings, and they have to be flat. So let's look at these figures and figure out why they're not polygons. Oh, there's an opening, can't be a polygon. There's a curve, can't be a polygon. And that one's a three-dimensional shape, right? Because it's a cube instead of just a square. So that can't be a polygon. Okay, so let's look here. In the book, they give you the name of some common polygons. It names the number of sides. So there's a triangle, 3 sides. A quadrilateral is 4 sides. A pentagon, 5 sides. Hexagon, heptagon, octagon, decagon, and dodecagon. So check those out. Make sure that you understand. You might have to look up some of the harder ones, but hopefully you'll get the hang of it. So let's look just a minute. A quadrilateral has 4 sides, and they drew a rectangle. You see right there? Okay, so let's see, make it crazy looking. Is that a quadrilateral? 1, 2, 3, 4 sides, right? Yes. Let's see, let's make another one. Is that a quadrilateral? Yep. Those are 2 tiny little sides there. So 1, 2, 3, 4. It has 4 sides and 4 vertices. So it doesn't really matter the shape as much as it matters the number of sides matter. Okay, so take note of that chart on page 199. That'll be helpful to you. Okay, so let's look at example 1. This figure is an example of a quadrilateral. Which of these shapes is not a quadrilateral? So remember, quad means 4. So 4 sides, 1, 2, 3, 4 sides. Oops, not 4 sides and 4 sides. So it has to be C because it has 6 sides. Remember what that 6-sided shape is called? Let's flip back and look at our chart. A hexagon. So it looks a little bit different, but it still has 6 sides. Okay, so let's look example 2. It says which of these shapes is not a polygon? So that one has straight lines. It doesn't have any openings and it's flat. So that's a polygon. Straight lines, no openings, and it's flat. Oop, curved lines. Got to be that one, right? Okay, so let's look at example 3. Name each of these polygons. So how do we name a polygon? We count the sides, right? So I'm going to start on the top and count the top one first and put a little tick mark so I know where I started. 1, 2, 3, 4, 5, 6 sides. Oh, we just looked that up. That's a hexagon. Okay, so I'm going to put a tick mark at the top and know that that's what I counted first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. That's a dodecagon. I love to say that word. And then this one, 1, 2, 3, 4, 5, 6, 7, 8 sides, and that's an octagon. What's another polygon that's an octagon? A stop sign, right? Because it has 8 sides. Okay, let's go move on from that list. Again, use it, look it up if you need to on that chart if you forget. We're going to talk about congruent and similar shapes. So congruent shapes are the same size and the same shape, even if they're turned in a different direction. So these shapes, all three, are the same size and the same shape. They don't really look like it, but if I cut them out and laid them on top of one another, they would look exactly the same. They wouldn't see any air between them. So same size, same shape, even if turned differently. Okay, so which two rectangles below are congruent? So congruent, remember, same size, same shape. So that one's the same shape, but not the same size. That one looks the same size and shape, but it's turned differently. And that one looks like it's a little bit bigger than A or B or C. So I think it's A and C. So those two figures, A and C, are congruent because they're the same size. And if I measured it, that side would be the same size as that side, even though they're turned in different directions. So A and C are congruent figures. So congruent figures are also similar. Similar figures are the same shape, but may not be the same size. So all congruent figures are similar, but not all similar figures are congruent. So these are similar triangles. If I look at this base, and let's say I doubled it to get that base, I would also double this to get this side. I would double this to get this side. So the proportions stay the same to make them the same shape. So let's look at which two triangles may not be the same size, but they have the same proportions. They're the same shape. So this one has a little right angle right here. Do you see anything else with a right angle? A 90-degree angle? No. Here's an equilateral triangle. Do you see any other equilateral? Oh, look at that one. Looks the same, doesn't it? This one's bigger, but it's the same shape. That one just looks all funny, that obtuse triangle. It doesn't even look the same at all, but B and D do. So B and D are similar figures. Okay, check out that chart on page 199. That'll help you. Good luck.